This lab experiments with the gelatin-silver process of developing black and white film. This process was very important in the 19th to 20th century because during this period it was the only form of film processing available. Therefore, if someone wanted a photograph, they had to understand and undergo this process. This gelatin and silver process was also very important because it allowed chemists to experiment with these chemicals and therefore further understand chemistry on a deeper level.
Also, it allowed everyday citizens to be exposed to and learn about chemistry through this process. Another important aspect of this project on the developing of film is that this process is still relevant and widely used today. Despite the fact that digital photography methods are available nowadays, many professional photographers continue to use film. Many serious photographers like the grainy quality and depth of color that the gelatin silver process produces in photographs. This is why the chemistry of this process is so vital to understand.
The purpose of this experiment is to determine whether different concentrations of developer affect the end result of the photograph.
So now we're going to change the concentrations of the developer and see what happens to the end result of the photo. Okay, now, so we have 250 milliliters of developer and 750 milliliters of water. We're going to mix it together. Okay, so this is the 25% developer. And then now we have 500 milliliters of both water and developer. So this will be the 1-to-1 ratio and have 50% of developer. And finally, we have 750 milliliters of developer and 250 of water, and this will be the highest concentration of 75%. Okay.
So we are in the dark room at the moment, and as you can see, the lights are turned on, but later when the experiment is actually done, the lights will be completely off, and that's why we can't film while the lights are off. This is a process where you expose the photo paper to light, and so that the picture will appear on it. What you do is you stick the negative through here and then shine light through it onto the photo paper for a certain amount of time using this timer, and then the room will all be dark, so only this will be shining down, and then it will expose the picture. So this is where the photo is actually developed. First you put it in the developer, and this will be the control developer, the one that's used in class, and then you put it in the stop bath for 10 seconds, and then it goes into the fixer for 2 minutes, which helps the photo retain its color after time. And then it goes into the wash for 5 to 10 minutes, which is just water. And these are our 3 other concentrations of developer that we're going to be substituting for the control developer.
Okay, so I'm going to put this in the developer now, and the exposed image should come out. So this is our image, and it's going into the stop bath for 10 seconds. And then this will be in for 2 minutes. And finally, the wash bath for 5 to 10 minutes. So now our photos are just developed and they're wet, so we have to put it through the dryer. We have 4 because of the 4 concentrations. One of them is the control.
And so one of them is the control photo, and then one was developed with 25% developer, one was developed with 50%, and the other one is developed with 75%.
So here's what we have.
As you can see, this is the control, which is the lightest photo, 25, 50, and 75.
Although you can't really see it properly, like the difference.
Yeah. At first, we couldn't really tell the difference between the different concentrations when we looked at them. As you can see, it's
pretty hard to tell.
Yeah, they're kind of similar, but...
Oh, after we scanned into the computer, we could see from the histograms that the darkness and color and brightness are actually different between each photo. So this experiment proved our hypothesis right.
And it showed that the higher concentration of developer produces a darker photo.